The second problem, another friend's distance d from you in feet after t seconds is given by d equals that absolute value. What does the 80 in the equation represent? We can answer this if we look back up here to this problem. It's what? How many feet away when? When? When we start, yeah, at 0 seconds. So it says starting from 100 feet away. And then notice that that 100 showed up right there. So this 80 means what? We are 80 feet away when we start, okay? Now what does the 5 in the equation represent then? Yeah, so this one up here was 20 feet per second. So that means we're what? What does 5 feet per second mean? So we're going 5 feet per second. Yeah, so we start at 80 feet away to start. And then we are going 5 feet per second is our speed. Okay? It's not a coincidence that those numbers show up like that. And that is usually what happens in algebra. You start to see those numbers pop up. So now we need to know at what times is she 60 feet away from you. Well, we're 80 feet away to start, and we're moving at 5 feet per second. They give us the equation, d equals absolute value 80 minus 5t, and we want to know when is she 60 feet away. So what are we going to do? Yep. Take the 60, plug it in right there for the d, and we get 60 equals absolute value 80 minus 5t. Now what? We have absolute value by itself already right here. Can I subtract 80 from both sides right now? No, I can't. I have to do case 1 and case 2 first. So case 1 is what? 60 equals 80 minus 5t. And case 2 will be what? Good, negative 60. The answer changes sign, equals, and the absolute value stuff stays exactly the same, 80 minus 5t. There's your case 1 and case 2. So in case 1, subtract 80, that's right, from both sides, and we get negative 20 equals negative 5t. So then we divide by negative 5, and we get, that's a positive 4 equals t. Positive 4 what? Seconds. So 4 seconds into this problem, you can't have a negative time. That's like going back in time, and we can't do that. So solve this one. What do we do? No. Subtract 80 from both sides. And we get?
Negative 130? I don't know. I just confused myself.
Negative 140. Think about 6 plus 8. It's 14. So 60 plus 80 is 140. Equals what? Okay, negative 5t. And now, good, divide by negative 5. And what do we get? 20 something. 28, what? Birds, seconds, equals t. 28 seconds, she'll be 60 feet away from us on the other side. We do have some special cases to talk about, cases where you have no solution. We haven't really mentioned that yet, but we'll see what happens here as we get going. So remember that I need to have the absolute value thing by itself before I can split it up and work with the absolute value. Okay, so is the absolute value by itself on this problem right now? Is it by itself right now?
No.
No. So I got to get it by itself first. What should I do?
Add the combine my terms, right?
No. Let's imagine for a second that this was 3 smiley face plus 12 equals 10. I want to solve for smiley face. Subtract 12. And then once I did that, I would... So I'm going to subtract 12, and I get 3 smiley face equals negative 2. And then I'm going to divide both sides by 3 to get smiley face by itself. Okay, so the answer would be negative 2/3. That's how you do this problem if it wasn't an absolute value. But this right here is like the smiley face. Okay? So we got to get that by itself first. And then we can do case 1, case 2. So let me get all that junk out of the way. And what am I going to do first here? Subtract 12 from both sides. Once I do that, I get 3 absolute value 2z plus 9 equals negative 2. Now what do I got to do to get the absolute value by itself? Yeah, divide everything by 3. So I divide the left side by 3. I divide the right side by 3. This is a fancy one right here, so that disappears. And I'm just left with absolute value 2z plus 9 equals negative 2/3. Now what? So I normally would do case 1 and case 2, but in this case we're not going to, because we need to remember what absolute value is. What's absolute value again? How far away means distance, right? Your distance from 0. And can distance ever be negative? No. So I have the absolute value of some stuff. The absolute value of anything has to be positive. But I have right here that the absolute value of something is negative. Can that happen? No. That can't ever happen. I can put whatever I want inside absolute value. I can put the Empire State Building inside absolute value. I can't get a negative result. Okay? So because this is a negative number sitting right here, there is no solution. I can't take the absolute value of something and get a negative answer. So therefore, I can't, this is just a false statement, okay? So you have to be aware that if you see a negative sign in the answer, absolute value of some stuff equals a negative number, there's no solution there. Now, if you didn't notice that and you split it into case 1 and case 2, you're still going to get answers, and it's going to seem like you have the right answer. But if you go to check your answer, you'll get false statements, okay? So I want to do that, actually, to show you that. So I'm going to split this into case 1 and case 2, and I've changed colors because this is not actually what we're going to be doing here. Don't do this. So that'd be 2z plus 9 equals negative 2/3. 2z plus 9 equals positive 2/3. Okay? Subtract 9 from both sides, and you get 2z equals, well, that's negative 27/3 minus 2/3, so that's negative 29/3. And at this point, probably a lot of you would just give up. Divide everything by 2, and you get z equals negative 29/6. If I take that negative 29/6 and I insert that right there, then I get negative 29/6 times 2, which is negative 29/3, plus 9. Well, that's 27/3, so that gives me negative 2/3. But the absolute value of negative 2/3 is positive 2/3. Positive 2/3 times 3 gives me 2. 2 plus 12 is 14. I don't get the correct answer. Okay? And the same thing would be true over here. I'd wind up with some sort of answer here. I'd come up here to check it, and I'd get a false statement. That's because you can never take the absolute value of a negative or of something and wind up negative. So you have to see this to save yourself the trouble of working with this problem any further. So let's take this one as well. What should we do to get the absolute value by itself? Good. Add 5 to both sides. And now what do we have? Yeah.
Isn't it no solution again?
Why is it no solution?
Because it's negative?
Because you can never take the absolute value of something and wind up negative. So this one is also no solution. All right. After absolute value equations, we're learning about absolute value inequalities now. It's handled exactly the same way. You're going to see absolute value of some stuff, but this time it's going to be like greater than or equal to some answer. So we're just taking everything that we've learned in this chapter and last chapter and throwing it all together in this one section right here. Don't be afraid of it though, it's not that bad. If you remember these three things right here, to solve an absolute value inequality, first, isolate the absolute value expression, just like we were just doing, okay? And now we know how to do that. So get the absolute value by itself. Remember, what happens in Vegas stays in Vegas. So what happens inside the absolute value stays there until you split it into case 1 and case 2. Split it into 2, like we did with absolute value expressions, or absolute value equations, okay? Case 1, case 2. I'm going to write that here. Case 1, case 2. And we are going to write case 1 and case 2. Now, in equations, remember what we had to do between case 1 and case 2. Everything stayed the same except for what? The answer changed sign. Okay? Now, split into 2 like we did, case 1 and case 2. And, in addition to making the other side negative, you're going to have to flip the inequality symbol in case 2. So flip the symbol in case 2. It's still called the negative case. So we have the positive case and the negative case. All you're doing is flipping the inequality symbol and changing the sign here. So for example, it says solve and graph. The first thing we want to do is check to make sure the absolute value is by itself. Is it?
Yep.
Yeah, it is. So we can split into case 1 and case 2 right now. Case 1 and case 2. For case 1, we will have exactly what we see. 8n is greater than or equal to 24. Hold on, we're not done. Case 2, the stuff inside the absolute value stays the same. It will be negative 24, and we also have to flip the inequality to less than or equal to. Now we can solve. So divide both sides by 8, and we get n is greater than or equal to 3. On this side, we divide by 8, and we get n is less than or equal to negative 3. The directions say solve, well we did, and graph. So, I draw my number line, I have a negative 3, I have a positive 3. It says n is greater than or equal to 3, so that's going to be a solid dot, and then shading to the right. This one says n is less than or equal to negative 3, so I'm going to put a solid dot, shading up and to the left. What kind of graph does that look like?
Or
That looks like an OR statement. That's right. We'll come back to that in a second. We have n minus 1 is less than 2. We want to solve this. We're ready for case 1 and case 2 right now because the absolute value is by itself. So we have case 1, case 2. Okay, what is case 1?
n minus 1 is less than 2.
Exactly what you see. What's case 2?
The n minus 1 is
What's inside stays the same. The inequality symbol flips and the sign of the answer changes. For case 1, what do we need to do? Add 1 to both sides, and we get n is less than 3. Over here,
plus 1.
and we get
n is greater than negative 1.
good. Okay, we have to graph this one as well. We have a negative 1, we have a 3. The dots will be what? Open. Now for negative 1 it says greater than, so that's to the right. For less than 3 over here it says less than, so that's to the left. What kind of a statement does that look like? That is an and statement. So we can connect the two arrows. That's an and statement. What's the difference? What's the major difference between those two problems? Well, we have an and an or statement. But look at the original inequalities. What's the big difference between the two? And, yes, and only looks like this. But come back up here. Look at this compared to this. Well, there was a problem here too. We had to divide by 8. What is the biggest difference between those two? The symbols. Yep. This one says greater than. This one says less than. It turns out that greater than or equal to is or. Less than or less than or equal to, when you're dealing with absolute value, is and. It's only when you're dealing with absolute value. Absolute value inequalities have that feature. If you see greater than symbols, it's an or statement. If you see less than symbols, it's an and statement. Okay, a little key concept here. Basically summarizes what we just saw in those last two problems. To solve an inequality that has absolute value is less than something, you'll wind up with what looks to be an and statement. To solve an inequality that has the greater than symbol and absolute value, you'll wind up with an or statement. Okay? So if it's absolute value, inequality, it's going to look like and or. So we want to solve, graph, and write our answer using interval notation. Let's also do set builder. Because why not? It's good practice. Solve, graph, write answers using set builder and interval notation here. So what do I need to do first on the one on the left? The absolute value is by itself, so case 1 and case 2. Some people do, and I'm okay with that. But I do want them labeled in some way. So what is case 1? Everything stays the same. What's case 2?
2x plus 4 less than or equal to negative 5.
Perfect. Flip the symbol, change the sign. Okay, on the case 1, subtract 4 from both sides, and we get? Okay. And divide both sides by 2, and we get? Okay. Okay, case 2, subtract 4 from both sides, and we get? Less than or equal to negative 9. And we get x is? What about the symbol? Less than or equal to negative 9/2. Now what kind of statement is this one going to look like? We saw greater than in the original problem.
Or.
It's one or the other. It's or. Yeah. So our graph will look like or. Let's go ahead and draw the number line. We have negative 9/2, so that'll be on the left. And we have positive 1/2, so that'll be on the right. For 1/2, it says greater than or equal to, so that's solid dot and to the right. And for negative 9/2, another solid dot, and less than is that way. So it did wind up looking like an or statement. So we have solved, we're graphed. It says right answer using an interval notation. So let's write set builder first. Squigglies, and our variable is x, so x such that we have x is greater than or equal to 1/2. And the word we're going to use is or. X is less than or equal to negative 9 halves. So there's your set builder notation. Yeah. And let's do interval notation here. I'll change colors. And I'm going to write interval notation right here. For my graph, which is where it's easy to come up with interval notation, what do I have? Negative infinity, but the symbol is parentheses, comma, negative 9 halves, and the symbol is bracket. I need a word. Or. We start on the left of the second one here, and that's bracket 1/2, comma, now is the positive infinity, and parentheses. So there is your set builder, or sorry, there is your interval notation. There is your set builder notation. There is your graph, and there is your solution. Like I said, on a test, you're going to be asked to do all four, so you might as well know how to do it. All right, see if you can do the second one now. Case 1 and case 2, solve both, set builder, graph, interval. So what do we do? Case 1, case 2.
5x greater than 20 greater than or equal to 20.
Case 2.
Less than or equal to negative 20.
All right, you're off the hook. Somebody else. Case 1, what do we do? Divide by 5 and we get? All right, case 2. And we get?
Less than or equal to negative 4.
Now what?
Graph.
Okay, we can draw a graph. We need a 4 and a negative 4. Good, they're both closed. Right. Okay.
Now, interval notation.
All right. We could do either.
Interval.
Fine. What do I start with? Interval notation.
Parenthesis.
Yeah.
Negative infinity.
Good.
Negative 4 bracket.
Bracket. Good.
Or.
Or.
Bracket 4, comma, infinity, parenthesis.
Nice.
Squiggly bracket. X such that x greater than or equal to 4 or x less than or equal to negative 4. Squiggly bracket.
All right. Moving along. A company makes boxes of crackers that should weigh 213 grams. A quality control inspector randomly selects boxes to weigh. So that's like, as the boxes are going down the conveyor belt, somebody has to stand there. And they just kind of sit there and kind of hum to themselves for a couple minutes, and then all of a sudden they reach over and grab a box that's going by. And they weigh it. And that's what randomly selects boxes to weigh means. Okay? To sort of spastically reach out and grab a box all of a sudden. Any box that varies from the weight by more than 5 grams is sent back. What is the range of allowable weights for a box of crackers? They want the crackers to weigh 213 grams. If you ever look on a package, it'll say like net weight is. Our net weight is going to be 213 grams. It could be off by a little bit either way. What's that? Yeah, so that's what they're saying. The whole thing, like they just take the box and all the stuff and they put it on a scale. They want it to be 213 grams. But if it's off by more than 5 grams, either way, then they're going to send it back. Probably more likely they're just going to put it under the conveyor belt, and then when they take a break, they grab the box and they go into the lunchroom and they just eat. No, probably not. But that's the idea, okay? So what is the lowest weight? Because this is asking, what is the range of allowable weights for a box of crackers? So what's the lowest weight that you could see on the scale and keep the box? Like we pull the box off the conveyor belt, we weigh it, it says this amount, and that's still okay. But anything less than that, no good. What would that weight have to be? 208, that's right. So 208 grams is still good. Is less than or equal to X is less than or equal to, what is the highest weight that you could see? 213 is the rate we want. 218. 218 grams. So if I reach out and grab a box off the conveyor belt and I weigh it, and it's between 208 and 218 grams, it's good. I put it right back on there. But if I weigh it and it's less than 208, so like 207 or lower, or it's more than 218, so like 219 or higher, then that box is no good, and I like put it on the cart over here, and then we're gonna like take that cart and send all those crackers back and try it over again. Okay, so that's the idea. That's called quality control, and actually they have it sitting right here. There's always quality control inspectors for everything that's made on an assembly line, like cars, things like boxes of crackers, boxes of cereal, stuff like that. Okay? What? So, okay, so what it says is if the box varies from the weight by more than 5 grams, we want it to be 213. It could be under, it could be over, but as long as it's less than 5 grams away from 213 either way, then it's still good to go. Okay? Well, 5 grams to this side, so let me draw a number line here. Here's 213. 1, 2, 3, 4. Since this is a number line, this would be 208. 1, 2, 3, 4, 5 on my number line, that's 218. Anywhere else is no good. In here, though, that is good. I can be 208, I can be 218, and I can be anywhere in between. What kind of statement does this look like? And. Which inequality gives me and? Less than or equal to 5. It says more than 5. Anything more than 5 over is sent back. So now inside the absolute value symbol, I have my weight minus the 213 that I want. If I weigh this thing and I get 211, then I have 211 minus 213, which is negative 2. The absolute value of that is 2. 2 is less than or equal to 5, so that one's good. Okay? If I weigh this thing and I get 217, 217 minus 213 is 4. Absolute value of that is 4. 4 is less than or equal to 5, so that one's good. If I pull another box off and I weigh it and I get 220, 220 minus 213 is 7. The absolute value of that is 7. 7 is not less than or equal to 5, so that box gets put on the other cart. It's no good. Okay? So this is the inequality that they're looking for here. This is the graph that you can form in your mind when you read the problem. It should weigh 213, but we need to be within 5 grams either way of that. Okay? So when you are presented with a problem like this, the formula you're going to use is this. Absolute value, x minus c, which is the number that you are supposed to have, is less than or equal to r, which is the range of values. This is r right here. This is c. So let's look at the second one. A food manufacturer makes 32-ounce boxes of pasta. Not every box weighs exactly 32 ounces, but they try to get it as close as they can. And then it says the allowable difference for the ideal weight is at most 0.05 ounces. Write and solve an absolute value inequality to find the range of allowable weights. So we're going to use this x minus c is less than or equal to r. And then we just plug in the numbers. This guy right here will be what? C or R? That's the R. It says within at most 0.05. So that's R. And then where's C at? That is the 32 ounce boxes. So that will be C. So we're going to write absolute value x minus 32 is less than or equal to 0.05. All that means is we're going to take 32 and add 0.05 to it and subtract 0.05 from it. And that's your answer. Or you could do case 1 and case 2. X minus 32 is less than or equal to 0.05. X minus 32 is greater than or equal to negative 0.05. Add 32 to both sides and you get x is less than or equal to 32.05. Add 32 to both sides and you get x is greater than or equal to 31.95. And this is in ounces, so we're going to write ounces here and ounces here. So there's your answer. But it comes from this inequality right there. That's one that you just kind of have to memorize. So put a big star next to it and write memorize or something like that. You got to know it. It pops up on quizzes and tests. And you'll know you got to use it when it says the ideal weight or quality control inspector, something like that. It tells you that this is like a range of values. And even if you can't get this, you can still kind of in your head say, okay, well I have to be within this amount so I can add and get one answer. I can subtract and get the other answer.